Now let's delve a bit deeper into how exactly these logical statements work in SQL. And here is a motivating example for you. This is a selection from the characters table, and we have a where filter, and this where filter is needlessly complicated. And I did this intentionally because by the end of this lecture, you should have no trouble at all interpreting this statement and figuring out for which rows it will be true. And likewise, you will have no problem writing complex statements yourself or deciphering them when you encounter them in the wild. The way that these logical statements work is through something called Boolean algebra, which is an essential theory for working with SQL, but also for working with any other programming language, and is indeed fundamental to the way that computers work. And though the name may sound a bit scary, it is really easy to understand the fundamentals of Boolean algebra. Now, let's look back at so-called normal algebra, meaning the common form that is taught in schools. In this algebra, you have a bunch of elements, which in this case, I'm only showing a few positive numbers, such as 0, 25, 100. You also have operators that act on these elements. For example, the square root symbol, the plus sign, the minus sign, the division sign, or the multiplication sign. And finally, you have operations, right? So in operations, you apply the operators to your elements, and then you get some new elements out of them. So here are two different types of operation. In one case, we take this operator, the square root, and we apply it to a single element. And out of this, we get another element. In the second kind of operation, we use this operator, the plus sign, to actually combine two elements. And again, we get another element in return. Boolean algebra is actually very similar, except that it's simpler in a way because you can only have two elements, either true or false. Those are all the elements that you are working with. And of course, this is why when there's a Boolean field in SQL, it is a column that can only have these two values, which are true and false. Now, just like normal algebra, Boolean algebra has several operators that we can use to transform the elements. And for now, we will only focus on the three most important ones, which are not, and or. And finally, in Boolean algebra, we also have operations. And in operations, we combine operators and elements and get back elements. Now we need to understand how these operators work. So let us start with the not operator. To figure out how a Boolean operator works, we have to look at something that's called a truth table. So let me look up the truth table for the not operator, and in this Wikipedia article, this is available here at logical negation. Now, first of all, we see that logical negation is an operation on one logical value. What does this mean? It means that the not operator works on a single element, such as not true or not false. And this is similar to the square root operator in algebra that works on a single element, a single number. Next, we can see how exactly this works. So, given an element that we call P, and of course P can only be true or false, the negation of P is simply the opposite value. So, not true is false and not false is true. And we can easily test this in our SQL code. So if I say select not true, what do you expect to get? We get false. And if I do select not false, I will of course get true. Next, let's see how the AND operator works. So we've seen that the NOT operator works on a single element. On the other hand, the AND operator connects two elements, such as writing true and false. And in this sense, the AND operator is more similar to the plus sign here, which is connecting two elements. So what is the result of true and false? To figure this out, we have to go back to our truth tables. And I can see here at the logical conjunction section, which is another word for the AND operator. Now the AND operator combines two elements, and each element can either be true or false. So this creates four combinations that we see here in this table. And what we see here is that only if both elements are true, then the AND operator will return true. In any other case, it will return false. So going back here, if I select true and false, what do you expect to see? I am going to get false. And it's only in the case when I do true and true that the result here will be true. And finally, we can look at the OR operator, which is also known as a logical disjunction. It's also combining two elements. It also has four combinations. But in this case, if at least one of the two elements is true, then you get true. And only if both elements are false, then you get false. And so going back to our SQL, true or true will of course be true. But even if one of them is false, we will still get true. And only if both are false, we will get false. So now you know how the three most important operators in Boolean algebra work. Now, the next step is to be able to solve long and complex expressions such as this one, and you already know how operators work. The only information you're missing is the order of operations. And just like in arithmetic, we have an agreed upon order of operations that helps us solve complex expressions, and the order of operations is written here. First, you solve for NOT, then you solve for AND, and finally for OR. And as with arithmetic, you first solve for the brackets. So let's see how that works in practice. Let us now simplify this expression. So the first thing I want to do is to deal with the brackets. So if I copy all of this part over here as a comment so it doesn't run as code, you will see that this is the most nested bracket, the innermost bracket in our expression, and we have to solve for this. So what is true or true? This is true, right? And now I can copy the rest of my expression up to here. And here I can solve the innermost bracket as well. So I can say true, and what I have here is false and true. So this is false, right? Because when you have AND, both of them need to be true for it to return true, otherwise it's false. So I will write false. Moving on to the next line, I need to solve what's in the brackets. So I can copy the NOT, and now I have to solve what's in this bracket over here. Now, there are several operators here, but we have seen that NOT has the precedence, right? So I will copy true, and here I have not false, which becomes true. And then I can copy the last of the bracket. I'm not gonna do any more at this step to avoid confusion. And then I have OR, and I can solve for this bracket over here, and true and false is actually false. Moving on, I can keep working on my bracket, and so I have a lot of operations here, but I need to give precedence to the ANDs. So the first AND that occurs is this one, and that means I have to start with this expression over here. True and true results in true. And then moving on, I will copy the OR over here, and now I have another AND, which means that I have to isolate this expression. False and true results in false. And finally, I can copy the final AND because I'm not able to compute it yet because I needed to compute the left side. And I can copy the remaining part as well. Moving on to the next line, I need to still do the AND because the AND takes precedence, and so this is the expression that I have to compute. So I will say true OR, and then this expression false and true computes to false, and then copy the rest. Now let me make some room over here and go to the next line, and I can finally compute this bracket. We have true or false, which we know is true. Next, I need to invert this value because I have not true, which is false, and then I have or false, and finally this computes to false. And now for the moment of truth, pun intended, I can run my code and see if the result actually corresponds to what we got. And the result is false. So in short, this is how you can solve complex expressions in Boolean algebra. You just need to understand how these three operators work, and you can use truth tables like this one over here to help you with that. And then you need to remember to respect the order of operations, and then if you proceed step by step, you will have no problem solving this. But now let's go back to the query with which we started, because what we have here is a complex logical statement that is plugged into the where filter, and it isolates only certain rows, and we want to understand exactly how this statement works. So let us apply what we've just learned about Boolean algebra to decipher this statement. Now, what I've done here is to take the first row of our results, which you see here, and just copy the values in a comment. And then I've taken our logical statement and copied it here as well. So let us see what SQL does when it checks for this row. The first thing that we need to do is to take all of these statements in our where filter and convert them to true or false. And to do that, we have to look at our data. Let us start with the first component, which is level bigger than 20. So for the row that we are considering, level is 12. So this comes out as false. Next, I will copy this AND, and here we have isAlive equals true. Now for our row, isAlive equals false, so this statement computes as false. Mentor ID is not null, with null representing absence of data. In our case, mentor ID is 1, so it is indeed not null. So here we have true. And finally, what we have in here is class in Mage Archer. So we have not seen this before, but it should be pretty intuitive. This is a membership test. This is looking at class, which in this case is Hobbit, and checking whether it can be found in this list. And in our case, this is now false. So now that we've plugged in all the values for our row, what we have here is a classic Boolean algebra expression, and we are able to solve this based on what we've learned. So let us go and solve this. And first I need to deal with the brackets. And what I have here, I have an and an or, and the and takes precedence. So false and false is false, and I will copy the rest. And here I have not false, which is true. Next, we have false or true, which is true, and in the end, this computes to true. Now, in this case, we sort of knew that the result was meant to come out as true because we started from a row that survived the where filter, and that means that for this particular row, this statement had to compute as true. But it's still good to know exactly how SQL has computed this and understand exactly what's going on. And this is how SQL deals with complex logical statements. For each row, it looks at the relevant values in the row so that it can convert the statement to a Boolean algebra expression, and then it uses the Boolean algebra rules to compute a final result, which is either true or false. And then if this computes as true for the row, then the row is kept, and otherwise the row is discarded. And this is great to know because this way of resolving logical statements applies not only to the where component, but to all components in SQL which use logical statements and which we shall see in this course.